Let us now understand the relation between luminous intensity and illuminance. And for proper understanding of illuminance, let us consider a source of light which emits a beam of light uniformly in a specific direction. And here in front of this light beam, if we place a white screen, this light beam will produce a circular spot on the screen which will be bright and produce illumination on the screen. Here, if we consider the area of this spot to be S and total luminous flux which is emitted by this light source is considered to be phi, then in this situation on this surface of a screen where light is illuminating this bright patch, here we can write illuminance I is equals to phi by S, which is written as the luminous flux per unit area, and its units are given in lumen per meter square. Now we can also relate the illuminance on a surface due to a light source in terms of luminous intensity. For this, say we consider a point isotropic source of light which is of total luminous flux phi. It is emitting the total flux phi in all directions. And in this situation, say at a distance r0 from it, we consider a screen, and if we just talk about the luminous intensity at this point A, then this IA we can simply give as the total luminous flux which is emitted in all directions. The flux which is reaching point A will be distributed, the total flux phi is distributed in a spherical region of radius r, and when it is crossing point A, it is passing through the total spherical surface. So per unit area, the luminous flux which is reaching point A normally can be given as phi divided by 4 pi r0 square. In this situation, we know well that in case of a point isotropic source at any point or in any specific direction, luminous intensity we write as phi upon 4 pi. In the previous section only we have studied it. So illuminance at point A can be given as luminous intensity divided by r0 square. This is a relation we can directly state. But this is valid only when the point where we are calculating illuminance and relating with luminous intensity, it is normally placed with respect to the direction of propagation of light. Say we consider a point over here, this point is say M, which is located at an angle theta with respect to the normal direction, and say this distance is r. Then here also we can find out the illuminance, but in that case if we consider a spherical surface of radius r, then in this direction, or if we consider this small section of area ds, here if we consider an area ds, then this ds we are considering normal to the direction of propagation, and for this area ds, if within this small solid angle d phi, small solid angle d omega, if the luminous flux passing is d phi, here we can simply write the illuminance at point M is equals to d phi by ds. And in this situation, if we calculate the luminous intensity in this direction, then L in this direction we can simply write as d phi divided by the solid angle in this region, and the solid angle we can simply write as ds by r square. This ds by r square. But if we talk about the area on which the light energy will be incident, that will not be ds, that will be on this surface, and that will be larger than this. So if this area is ds prime, and if in this situation this angle is theta, this will also be theta. So here ds prime we can write as ds by cos theta. So in this situation on this surface where light energy is incident, it is ds prime. So here in this situation ds we can write as ds prime cos theta, So here you can see the value of luminous intensity we can write as r square d phi divided by ds, we can write as ds prime cos theta. So in this situation here you can see d phi by ds, which is the illuminance at point M on surface. This is not on surface, this is in the direction where light is passing through the area ds normally. So here if we calculate, here we can write I am perpendicular, and here if we calculate illuminance at point M on a screen, then this illuminance at point M on a screen we can write as d phi by ds prime, because d phi is the flux passing through this area ds prime, then d phi by ds prime we can write as L cos theta by r square. So this is the relation you need to keep in your mind, that is giving us the illuminance at point M on the screen, which is located at a distance r from the source and at an angle theta from the normal direction.